All right, so number one here, right? We're doing this by elimination. Okay? Can anybody tell me why we would do this by elimination? Gavin?
Because 5y has the same.
Yeah, we have 5y's in both. And in fact, in this one, it's even easier because what's already true? What's true about the 5y's in these two equations? Not only are they the same, but they have opposite signs. Now, the reason this is easier is because instead of subtracting the bottom equation, I'm just going to add the bottom equation. Okay? And the reason I'm going to add it is because they already have opposite signs. So they're already going to cancel out, right? Because 5y minus 5y is 0, goes away, right? So this is like the perfect, easiest scenario for elimination, right? They're opposite signs and they have the same number, so we just add them together, okay? And when I do that, what do I get here? What's 3x plus 2x, class? 5x. And what is negative 27 plus 7? Negative 20, okay? So now when I divide, okay, I'm going to end up dividing this by 4, or by 5, just one second, Destiny. And so I get x is equal to negative 4, okay? Destiny, what's that?
Where did Mr. Lazenby go?
What room is Mr. Lisby's room? Those of you that know.
Downstairs.
It's straight under us, so go down the stairs and then it should be just right under, down there. Okay, so x equals negative 4. Okay, we got that? Okay, now we're going to take that negative 4 and we're going to plug it in. Does it matter which equation? What do you guys think? Does it matter which equation?
No.
No, it doesn't. Okay, I'm going to choose the second one. Why would I choose the second one? There's a 5 there, sure, but there's a 5 in the top one too. It really, what's that? There's not a negative on the other side, so that's part of it. And the numbers are smaller, right? So if I can deal with smaller numbers, that's easier to think through mentally, right? I'm more sure that I'm not going to make mistakes. So I'm going to take that negative 4 and put it in my second one. So right here, now I'm going to get 2 times negative 4 minus 5y equals 7. Okay? Everybody with me? We should be writing all these things down. At the end of the day, hopefully we'll have about half of this done. The other half will be your homework for today. Okay? So, 2 times negative 4 is negative 8 minus 5y equals 7. Yes, Aaron?
I got that paper.
Oh, it's right back there. Blue paper back there on that shelf. Will you grab it? Okay. Casey, you with us? Somebody kick him. Casey. Make sure you're with us up here. Okay. So now we're going to add 8 to both sides. So I get negative 5y is equal to 15. Okay. And then last thing I'm going to do is divide by negative 5, right? So my answer here is y is equal to negative 3. But what is my final answer? How am I going to write my final answer to this system? Go ahead. You'll get the next one.
Negative 4, comma, negative 3.
Right, my answer is negative 4, comma, negative 3. X, comma, y. Okay, everybody make sure that you have that stuff written down. Yes.
So how do you get 5x from the elimination from these two?
What's 3x plus 2x?
3x plus 2x.
Yeah, that's where the 5x is
Oh, I
coming from.
thought you did 5.
No, because I added this whole bottom equation to this whole top equation. So 3x plus 2x is 5x.
Grab them all.
Right, and then 5i minus, and that's 0. And then, we got that? Okay. All right, so, any other questions? Good question, thank you, Gavin. Any other questions on number 1? Okay, let's look at number 3. So number 2, notice that number 2 is exactly, it's very similar. On number 2, we aren't going to do it together, but which variable are we going to get rid of?
The third,
X, right? Why are we going to get rid of X?
because they have opposites.
Okay. They have opposite signs, same number, right? So let's look at number 3. What's different about number 3? Calvin?
They have the same signs, same numbers.
Now they have the same signs, right? So in this case, I have to subtract the bottom equation, okay? So if you need to make a note to yourself, make a note to yourself. But when they have the same signs, we have to subtract one equation from the other, Okay, so in this case, I'm gonna start by subtracting this bottom equation right here. Okay? And when I do that, this is gonna, negative 6x minus negative 6x is 0, right? Well, what's negative 3y negative 3y minus negative 3y?
0.
Also 0.
So,
And what is 7 minus 6?
1.
1. What do we see that is a problem here?
You have 2 zeros in it.
Is 0 equal to 1?
Yes.
No, 0 is not equal to 1, so what do we say?
No solution.
There is no solution. Okay? So, whenever we get something that is not true, right? And this is true all the time in math, right? We've talked about this all year with solving linear equations. We've talked about it with solving inequalities. If we get something that is just simply not true, then there is no solution, right? And in this case, 0 is not equal to 1, so there is no solution. Okay? Now, in the spirit of that idea, before we go to, well, we're actually going to do 5 and 6 together, but before, we're going to do it backwards. We're going to do 6 first, then 5. Okay? So looking at number 6 here, okay? What's different about 5 and 6 than is different from the other ones that we've done so far? Right? We're going to have to create variables to eliminate. So what Riley said is absolutely right. We have to multiply one of our equations by something. Okay? So in this instance right here, if I multiply the top equation by 2, which variable will I be able to get rid of?
14.
Not 14, but
9.
no, which variable?
19.
So,
X.
Which x, right? We're getting rid of x. So over here, what would I multiply this equation by to get rid of a variable? I heard somebody say it up here.
2, yes.
Also 2, right? Because if I multiply 8 by 2, I get 16, right? Which is what I want.
Like 10 by 2, that would also give you,
And we'll get to that in just one second. Anthony's noticing something that we'll talk about here in a moment, okay? Which is great, okay? So if I multiply this top equation by 2, now what I'm getting here, what's my result? If I multiply this by 2, what do I get down below? Negative 14x
8y
plus 8y equals, what's 19 times 2? 38, thank you, Austin. Okay, now I'm just gonna add these straight down, right? Because I have a 14x here and a negative 14x here. So I'm just gonna add straight down because they have opposite signs. So as I add, I'm gonna get 0 right there, goes away, which is what we wanted, that's the goal, right? 14 minus 14 is 0. 6y plus 8y, what's that gonna give us? 14y. And 4 plus 38 is going to give us 42. Okay? What do I do next? Divide by 14, right? So if we're dividing by 14, we're going to get y is equal to 3. So there's my half of my solution. Okay? Does anybody have a question about how I got to this point so far?
Wait.
Yes, Clayton.
So I got 0.33 continued. So wouldn't we just move the 3 over?
Flip it over. So 42 divided by 14. Yeah, you did 14 divided by 42, right?
Yeah.
Which is 1/3 or 0.3 repeating.
Okay.
Okay? All right, so now what are we going to do with this 3? We've done it a lot already. What are we going to do with it now?
Plug it into your other equation.
Okay, does it matter which one?
Nope.
Not particularly. So in this case, let's say
6.
the bottom one because they're all positive, right? And the numbers are a little, at least 4 smaller, so let's just do that one. So I'm going to plug 3 in right there. So 14 times 3 plus 6y equals 4. 14 times 3, we just kind of actually did this, right? 14 times 3 is 42. 42 plus 6y is equal to 4. Okay, now we're going to subtract 42. So I get 6y is equal to negative 38. Does that make sense? Is that right? I feel like I'm making a mistake.
Yeah.
Oh, I plugged it in for x instead of y, right? So there was my mistake. Okay? Oh, come on, now you're gonna do this to me now. Alright, so we're gonna do this. Okay, so 14x plus 6 times 3 equals 4. Okay, and now we're gonna solve. Now it's in the right spot, right? We can't plug y in for x, that doesn't make any sense. Okay, if any of you notice mistakes like that, right? I occasionally make mistakes, right? And it's certainly welcome to correct me. Okay, so 6 times 3 is 18, so I really get 14x plus 18 equals 4. And now I'm gonna subtract the 18. So I get 14x equals negative 14, and now this makes more sense. Okay, and then I'm lastly gonna divide by 14, so I get x is equal to negative 1. Okay, so our solution here is going to be written as an ordered pair. Okay, let's see, James, what are we gonna write as our solution? We know x, we know y. Negative 1 comma 3. Okay, there's our solution. Okay, now I said I wanted to talk about number 6. So let's talk about number 6. Okay, if we multiply the top one by 2, everything by 2 here, what's going to happen? Riley?
0 equals 0.
Wait, let's do the first step here first. So I get, what's 2 times this stuff? 16x minus 20y equals 0. What do we notice about these two equations? They are identical. So what's going to happen when I subtract the bottom one from the top one? Everything's going to go away. I'm going to get 0 equals 0. Now here's the thing. Is this a true statement?
Yes.
Yes. Is it always true? No matter what, right? So what's our answer? There are infinitely many solutions. Okay? Infinitely many. Infinite solutions. Okay? Remember the difference between those two things. When there is something that is never true, there is no solution. When it's something that is always true, there are infinite solutions, right? This is something that just should continue. We should always remember that. That's the principle that I do. Okay? What do we notice about number 7 that's different? 7 and 8 are different in a way.
Everything's off by 1.
Okay, everything's off by 1. That's true in number 7. Not necessarily number 8, but that's true. That's a good observation. Is there something that I can multiply one equation by to get the variable equal to the other equation?
Could you combine the 26 and 27 to get 1?
You can't yet. No, we can't add them together yet. First, we need to have a variable that is the same in both. And if I'm looking at this, if I multiply my top equation, like what would I multiply 9 by to get it equal to 10?
1.
No, that's what I'd add. What would I multiply 9 by to get it equal to 10? A fraction, right? Some terrible fraction. What would I multiply 7 by to get it equal to 8? Some terrible fraction. So whenever this is the case, and I would make a note right here. Does anybody have an idea what you might do? You could try substitution if you felt better. But here's what I would do if I was doing elimination. Multiply both equations by something different, right? So if I multiply the top equation here by 7 and the bottom equation by 8, what am I getting rid of by doing this? The y's, okay? So for the top equation, I'm multiplying by what the bottom equation is, okay? For the bottom equation, I'm multiplying by what the top equation is. Now notice what happens when we do this. When I multiply the 7 through, I'm going to get 63x, which is a big number, minus 56x equals, and I don't know this, 26 times 7. Help me out, calculator, quickly please.
It's
180.
What is it?
7.
Oh, thank you. That should be a y right here. What is it right here? 182?
I got 702.
182?
Yeah, that's what I got.
Okay, 182. Okay,
You didn't put a 2.
and then,
Warren's wrong. You didn't put a 2.
Is that a 2 or a 7?
I got 7 or
or
2.
Z?
7 times 26.
Oh,
That's what we're doing right there, right?
yeah. I was confused.
Okay. Now, on the bottom one, if we do 8 times this stuff, we're going to get 80x minus 56y equals 8 times 27, but I don't know what 8 times 27 is either. What is it?
216.
216?
Yeah.
What have we done by doing it this way?
We've created
There's 56.
Right. What Austin's trying to say, right, is we created an equal variable, and which one is equal, which variable, Y. right, the y. So now, what am I gonna do?
Subtract.
Subtract the bottom one from the top, okay? So if I subtract the bottom from the top, now we're gonna get negative 17x. These go away, which was the point of what we were doing, okay? And then 182 minus 216. What does that give us, like negative 34? Somebody check that for me, is that right? Negative 34. Okay, now what? Now we need to divide by negative 17, right? Divide by negative 17, and we're gonna get x is equal to positive 2. Now here's the thing, this is why I prefer elimination, okay? Because if you figure out what to multiply by, you will always only have one step left after you do the elimination to get our first part of our answer. Okay, this is why I prefer that. Okay, where in substitution, we usually have to do a bunch and then do a bunch to get our first answer, right? So this is why I prefer elimination. Now, it can be trickier to see what to multiply by, okay? But one thing I always remember that will always work is if we just want to multiply, if we want to get rid of y, just multiply the top equation by whatever the bottom one is, and multiply the bottom equation by whatever the top one is. And then that will always make it so they cancel out and go away. Okay, so now I'm going to take that 2 and I'm going to plug it in. Doesn't really matter. Both equations are equally bad here. So I'm going to plug in 2 in the top one. So 9 times 2 minus 8y equals 26. Okay, 9 times 2 is 18. Minus 8y equals 26. Subtract the 18, so I get negative 8y is equal to negative 8. Or should I 8? Positive 8? 26 minus 18 should be positive, I think, because 26 is bigger, right? So then we divide by negative 8, and we get y is equal to negative 1. So what's our final solution going to
2
be?
comma negative 1.
2 comma negative 1. Thank you, Blaine. Okay, and there's my answer. Okay. Now the purpose of this is not to like convert you to wanting to use elimination for everything, but the purpose is to see all the ways that we can use elimination. Okay, these are all the different ways we can try to use it. So I've left so far 3 of these elimination ones for you to do, but before we finish, I want to go over a few substitution examples, okay, of how to do it. Okay, am I safe to assume that we can skip these first types that both say y equals?
Yeah.
Are we okay skipping that? Understand that all you have to do is set them equal to each other. So really just put this right there. So we get this, negative 7x minus 5 equals negative 2x. Then solve for x and plug it back into one of them. Okay? One thing I do want to touch on really quick. What's unique about this problem? What's different about it? Yeah, that's half of our answer already, right? We already know. So whatever our answer is at the end, it will be something comma 6, right? No matter what. Because we already told us y equals 6, right? So normally part of our job is trying to find what x equals and what y equals. They already told us what y equals, so all we have to do is plug it back in. Okay? So let's move on. Then let's flip the page over. I think I also think 11 and 12 you guys are probably okay with, right? What are we going to do with 11 and 12?
Plug them in.
Yeah, it's already solved for y in one of our variables, right? So I'm going to take that and put it in y right there. Okay? Do we want to go through this together, or do you guys want to focus on 13 and 15? Focus. How many of you would rather just move to 13 and 15? Okay? All right, I think that seems to be where we can get more help. Okay, so 13 and 15. Okay? So this is where we're going to focus our time. Okay? So the hard part about this is do you know what I would do in these cases? not substitution, right? But we're gonna talk about how to do it by substitution. I would do this by elimination, right? Because I would multiply the bottom equation by what?
7, negative
Or,
7,
or,
4.
or 4, right? Either one would get me so that I have like terms. Yeah, clear.
So when already half of it is solved because you already got y.
No, because this one has x and y,
Okay.
where that other one had just y. Y equals whatever. Right?
When you're multiplying the equation, you have to do both bottom and top.
No, you can, if you can multiply just one, that works. But if you need to multiply both bottom and top, you can. Okay, but in this case, let's talk about doing it by substitution. Okay, as much as I prefer elimination, let's talk about doing it by substitution. So in order to do substitution, we need to solve for a variable. So make sure everybody's looking at 13 here with me. We're going to start by just adding y to both sides. Okay, now the reason I'm adding y is because x is already positive, right? So it doesn't make sense to me to solve for y in this case because I'm going to have something that's negative that's going to cause more issues. So I'm going to solve for x. I think I said that all right. So this is going to give me x is equal to y minus 2. Okay?
Why are you plussing by y again?
Because the y was negative and x was positive. And all we need to do is get one variable alone. Doesn't matter which variable, we just need to get one of them alone. Okay? Now, we're going to take this y minus 2 and plug it in place of x in my top equation, right? This is what substitution means. We're taking out one thing and replacing it with what it's equal to. Okay? So now, when I write this out, I have 4 times y minus 2 minus 7y equals negative 23. Okay, we've substituted. Okay, so now I'm just going to distribute my 4. So 4y minus 8 minus 7y equals negative 23. And now I need to solve for y. So I'm running out of space, so I'm going to move to the right over here. 4y minus 7y is negative 3y. Minus 8 is equal to negative 23. Okay, I'm going to add 8 to both sides. So I have negative 3y equals negative 15. And finally divide by negative 3. So y is equal to 5. Now, if you feel more comfortable with substitution, this is what you're doing, right? But hopefully you can also see a little bit why I prefer elimination. I had to do a lot of work to get half the answer, right? So now what we're going to do is we're going to take that 5, though, and we're going to plug it in. Can anybody tell me where the easiest place is to plug this in?
The bottom one?
This one right here?
Yes.
I think that'd be pretty easy, but there's actually an easier place to plug it in. And it's not one that was already printed. It's one that we've written, right? This equation right here is already solved for x, right? So I'm going to take my variable and plug it into this equation because it's already got x alone. So then I don't have very much to do. So now I get x is equal to 5 minus 2, which is 3. So my solution ends up being 3 comma 5, right there. Okay? And as I keep saying, both methods will work, I promise. Okay? However, right, you just have to get comfortable with one of them. Okay? Now if you're comfortable with both, that's going to make it easier because you'll have more options, right? There are some problems that don't seem to set up very nicely for substitution, so elimination seems to work out. Okay? There are some problems that don't seem to set up very nicely for elimination, so maybe substitution works out. Okay? But we have to be able to do one or the other. Okay? Having both at your in your toolbox is easier. Okay? So let's do number 15 together. Okay? Which variable seems easiest to solve for if I'm looking at those equations?
Top one.
Top one? Why?
It's smaller.
Smaller numbers, so which variable, x or y?
Wow.
Okay, why would I choose to do y instead of x?
I'm not sure.
What's that? Because then you don't get terrible fractions, right? If there's nothing in front of y, you don't have to divide by anything, right? So you're gonna get nice numbers to deal with. So we're gonna get this y alone. In order to do that, I'm gonna subtract the 3x, so I get negative y is equal to negative 3x plus 7. Okay, make sure you're writing this down with me here. And then I'm gonna divide by negative 1. So I get y is equal to 3x minus 7. Okay, so y has to be completely alone. Okay. We're going to take this number, or this 3x minus 7, and put it in place of y right there. Okay.
So would it be 7x times minus 5y times
Minus 5 times, we're not having the y there
3x
anymore.
minus 7
3x minus 7
as well?
equals 11. Good. Okay. So now we're going to multiply that negative 5 through. So 7x minus 15x plus 35 equals 11. Okay. 7x minus 15x is negative 8x. And I'm going to go ahead and subtract the 35 over. So 35, what's 11 minus 35 going to give us? 11 minus 35.
Negative 24.
Negative 24. And then when we divide by negative 8, I'm going to get x is equal to 3. Okay. Now I still need to plug that 3 back in someplace. So let's do it into this equation, right? Again, the one that we've already solved for y, this is going to be the most efficient, easiest way to use this.
So it'd be 3 times 3 minus 7.
3 times 3 minus 7, right? Okay. 3 times 3 is 9. 9 minus 7 is 2.
Following students, please come to the office. Joshua Blankenship, Emma Anderson, Cameron Roper, Austin Yancey, Hannah Watson, Gabriella Gowan, Damian Maney, Cameron Craney, Carly Eubanks, Peyton Knoll, Nicholas Clark, Josh Jackman, Isaac Lowe, Abby Bittner, Lexi Jones, Peter Grunig, and Kylie Cook. Thanks.
Okay. All right. So, on a scale of 1 to 5, I want to know how comfortable you're feeling with solving systems right now. Oh yeah, Bell's different today. So, the rest of this is homework due on Friday. Remember, you're going to your special flex classes today. Special flex classes because of the ACT stuff. Keep your learning check. Please get this homework done by Friday, okay? I'm expecting us to do that. You guys did a good job today. Please make sure that we get that done as well, okay?
No, you